In this lecture, we'll discuss about the column chromatography. Two kinds of column chromatography. One is adsorption. The second one is partition column chromatography. So, first we will see what is adsorption column chromatography. So look at its terms. So column chromatography, as we see in the last lecture, uses a packed column. Column is packed mainly in a glass tube or in a steel column, and here the adsorption means the principle of separation of the components in the mixture is based on the adsorption of the components. So adsorption has to take place. One of the medium should be the solid medium. Okay, so here the stationary phase will be solid, and here in this particular example, the mobile phase is a liquid. So first we are going to see what is liquid solid adsorption column chromatography. Okay. So in the previous lecture, I have mentioned that in any chromatography technique, there are two immiscible phases. One is the stationary phase and the other one is the mobile phase. So here, the stationary phase is a solid packed into a column. Normally we pack the column in a glass tube. So the solid phase could be either silica gel, alumina, cellulose, those kind of stuffs. So the mobile phase is a moving liquid, obviously, because here we are discussing about the liquid solid adsorption chromatography. So normally the liquid or the solvent what we use is petroleum ether, acetone, benzene, hexane, those kind of solvents that what we use as mobile phase in liquid solid chromatography. Okay, so next is what is the principle behind the separation or the retarding force which is felt by the retarding force felt by the components when those components are moving through the stationary phase. So the retarding force is in the form of selective adsorption. It's very important. Selective adsorption. You know what is adsorption. So selective adsorption means in your mixture there are different components are there, and the solid or the stationary phase, for example, silica gel, alumina, cellulose, whatever the stationary phase what we use, that phase adsorb your components differently or selectively, or some of your components has more adsorption to this stationary phase compared to the other component. So that selective adsorption is the principle of separation in adsorption column chromatography. And the driving force, of course, in the form of the flow of the mobile phase. And here it is the liquid, since we are discussing about the liquid solid column chromatography. So these are the main principles or these are the main components involved in liquid solid adsorption chromatography. So let's see what are the processes in a liquid solid adsorption column chromatography. So if you remember the YouTube link which I sent to you when we start this class first, so if you remember those steps, so those steps were regarding the adsorption column chromatography. So the first step is the packing of the column. This is very important. So we have to pack the glass tube with the stationary phase. Silica gel or whatever be the solid stationary phase we are using. So we have to pack the column with that one. So here you can see that. So we take a Bureau type column and we mix our stationary component, the solid phase, silica or alumina, with a proper solvent. So normally we use hexane, petroleum ether, benzene. So we mix these stationary phase with the solvent and we pour into the glass tube. And the next is the introduction of the mixture sample dissolved in a suitable solvent. So if you look at here, so after packing the column, we add more solvent and we allow the solvent to come out, so that the solvent, when the solvent moves down, it will settle the solid components properly, so that you will get a finely packed column. So the packing of the column is very important. There won't be any crack or any free space or air bubbles trapped in the column. If that happens, then that will affect the separation efficiency. So the packing of the column is very important. And if you're interested, you can again watch that video link. And then we will introduce the mixture. So your mixture, first we will dissolve in a proper solvent, and we introduce here. Then the next is the partial separation of the components. So when this mixture goes to the solid state, the components in the mixture will separate based on the selective adsorption. And next is the development of the chromatogram. So development of chromatogram is nothing but the separation of the components in your mixture. So here you can see that we are always top up this burette, the column, with the our solvent, because don't let the column to dry at any time of your separation process. So you have to take care of that. So always you have to top up with the column, and also that is your mobile phase. So this liquid is your mobile phase. So when the liquid flows here, that will take your mixture as well. So when your mixture comes down in the stationary phase, then due to the selective adsorption, the components in the mixture starts to separate, and that's what we call the chromatogram. And we will add more solvent here, and that will increase the separation of the components in the column, and that is what we call the development of the chromatogram. So you can improve the chromatogram by passing more solvents. Okay, so next step is the elution. Elution is nothing but you have to extract your components individually after separations. You have to get it back, your components individually. So that is what we call the elution. So to do that, the solvent, the liquid what you are adding is what we call the eluent. So eluent is the liquid or liquid mixture sometimes, which you are adding to the column to separate, to extract the individual components. So here you are taking a solvent. As I told you, it could be the petroleum ether, or what do you call the hexane, or kind of stuffs. Okay, so sometimes the eluent will be the same solvent what you are adding here. Suppose if you are adding the solvent here, if you top up the column with the solvent, and that solvent itself take your components until here, then you don't have to add any other solvents. You can use the same solvent. But sometimes your components won't come out if you are adding simply the solvent what you are using here. So you have to change the polarity of your solvent. So for that, you will add some polar solvents, or you will take a mixture at the final stage. For example, if you add some ethyl acetate to petroleum ether, that will increase polarity of the solvent, and that helps your components to come out. So for that, the liquid mixture or the liquid mobile phase what you are adding at the final stage is called the eluent. So the purpose of eluent is to extract the components in your mixture. Okay, then the final stage is removal of the solvent to obtain the pure components. So obviously, when you get your components separated here and here, for example, in these beakers, so you will get your component plus the mobile phase that will also with your component. So you have to separate the mobile phase from this beaker. So normally we will evaporate the solvent by using a rotary evaporator. So the solvent get evaporated, and you will get your component left in the beaker. So these are the processes involved in adsorption, column chromatography, liquid solid adsorption, column chromatography. So here I have given a series of pictures where a column chromatography is happening. So if you start from this picture, for example, this is the column, and the white color stuff is stationary phase, and here your mobile phase will be here. And if you open the knob here, so the mobile phase will come out. At the same time, it will take your mixture through the stationary phase, and here you can see that this black colored, what we feel black color, that is your mixture. And when the mobile phase take that mixture through the stationary phase, we can see that the color band is separating, and if you go from here to here, the separation is increasing. That means the development of the chromatograph, and finally you can collect each component. So here you can see the components clearly because the components has different color. But as I told you, that's why the scientist who did column chromatography first time, he named this technique as chromatography. The result is written in color. But I told you that chromatography is applicable to any organic components, even if it is not colored. So there are some other technique to determine whether your component comes out. So then let's see what are the applications of liquid solid column chromatography. So one of the main important aspect of column chromatography is you can use this technique, the adsorption column chromatography, to separate isomers, example position isomers. So you know that isomers are very similar in their structure. So I mean their molecular formula and a lot of steps are similar to each other. So it's very difficult to separate isomers, but you can use this liquid solid column chromatography to separate position isomer. For example, ortho and para-nitroanilines. You can separate ortho and para-nitroanilines by using alumina column. So your stationary phase is alumina, and by using a benzene solvent, and again geometrical isomers, for example maleic acid and fumaric acid on silica. So here the stationary phase silica, and even enantiomers, for example racemic camphor, by using a chiral column. So if you want to separate enantiomers, then you have to use a chiral column packed with the D-lactone. I mean chiral column here, for example D-lactone. So this is very important, or this is very important application of adsorption column chromatography, that you can even separate isomers by using this technique. Then in the identification, separation and purification of natural products, proteins and other organic compounds, you can separate by using this liquid solid column chromatography. The next application, the concentrating solutes from various solutions. So what do you mean by concentrating solutes from various solutions? For example, if you have a mixture, a huge amount of mixture, okay, and you want to get the components separated, okay, so when you do a chromatography, column chromatography separation, you will get your components separated. For example, if your mixture has 5 components, then you will get 5 beakers of your different 5 components, okay. Then you will take the another fraction of your mixture. Again, you will do the chromatography separation, so you will get again next 5 beakers with 5 different components. So beaker 1 in the first chromatography separation and the beaker 1 in the second chromatography separation, that contain the same components. So if you add those 2 beakers together, that means your components getting concentrated. So that means you can do the adsorption column chromatography of the same mixture in different times, and you will add the same components together. So that means the concentration of the components can be, the solutes concentration can be increased, or you can concentrate the solutes from various solutions. Then the other one is, this is extensively used in research and development labs for various industries. So chromatographic separation is one of the most important research and development equipment in chemical industry. So these are the applications of liquid solid adsorption column chromatography.